We present a method for synthesizing temporally coherent example-based paint strokes. State-of-the-art methods for animation stylization can produce very compelling visuals by rendering 3D paint strokes in screen space. However, in order to accommodate the dramatic deformations strokes can undergo when projected onto the screen, they resort to simple procedural brush models. Recent advances, such as RealBrush, can synthesize realistic strokes of arbitrary length, as well as complex paint effects using a library of example strokes. These results are an exciting direction to extend the range of styles achievable with 3D painting. Such methods, however, are not designed for temporal continuity. Naively stretching or shrinking realistic brushstrokes in screen space will stretch or shrink their local details, such as the paper grain visible in these examples. Attempts at continuously stretching such textures include seam carving, which exhibits similar issues, or slam textures, which are designed to infinitely stretch self-similar brushstrokes and are not appropriate in the case of realistic paint strokes. We present the first example-based method for synthesizing temporally coherent paint strokes. We represent each painting medium by a library of strokes acquired from the physical world. We create cuts in a given paint stroke and use the acquired library of strokes to find suitable patches that can be inserted in the cuts. The patches are deformed to match the stroke cuts, and we apply Poisson blending to obtain the final stretch stroke. We can synthesize shorter strokes in a similar way by removing patches from the original one, and thus obtain a hierarchy of paint strokes of varying lengths. The method we introduce lets us continuously blend between strokes at different levels of this hierarchy. We can iterate this process to synthesize arbitrarily long strokes. In the case of 3D paintings, the screen projection of strokes can exhibit large changes in length and shape. Our method is the first to accommodate for those deformations by synthesizing temporally coherent example-based paint strokes. Previous methods for example-based paint stroke synthesis require an entire stroke shape before they can synthesize the paint stroke. By pre-computing the stroke hierarchy, we can synthesize paint at interactive rates at runtime and provide immediate visual feedback to artists in the case of 2D painting applications. The following results demonstrate the ability of our method to accommodate for various styles, large deformations, and complex paintings. Thank you for your attention.